I thought that it will get over by 11:30, but it took huge time. I'm very sorry for that. Okay, shall we start or shall we wait for 5 minutes because others are to join? Here AC is not working and maybe it will start. Okay, shall we start now?
Yes, sir.
So all ACs are not working properly. I don't know. Okay. Uh, I'm sharing a slide. Is it visible? Am I audible? Hello. Sorry.
Yes, sir.
Yes, sir. Okay. Actually my speaker was off. I'm very sorry. Maybe you are telling me, but I'm not. I was not able to hear you. Okay. The module one which we had seen uh, till now, that uh, that has a basic assumption, and that is uh, the players, they have perfect information uh, about the maybe strategies, maybe the payoff and the outcome of these strategies, and possible actions and reactions. Okay, but uh, in real life, it is not like that. Correct. So, how to handle real life scenarios as far as the game theory is concerned, uh, and how to address to reach the Nash equilibrium. That's the task which we wish to know. That is what is imperfect information scenario as far as the game theories are concerned. Okay, are you understanding what I'm talking about? So Bayesian games actually are nothing but the games, static games with the imperfect information. Okay. So if someone wants to study the imperfect information games, or the games with imperfect information, it is nothing but the Bayesian games. Okay. Is that clear? Done? Are you understanding what I'm trying to tell? See, what we have seen the games is with the complete information. In these games, we know that there are n number of players. Then each player has some AI set of actions. Correct? Correct? And a game form that maps into the profiles, into outcomes. That is what we call it as the payoff or utilities over outcomes for each player. Okay. Utilities are nothing but the player's payoff from each of the action. Correct? Are you able to understand what we have already done it? Correct. So in complete information, we know that the actions of each player are assumed to be known by other players. Correct.
Yes, yes, sir.
And all of these components, that is players, actions, or the strategies available to all players, and the associated payoffs, we know that these games were static one, and they are with the complete information. So all these things, that is a number of players, then the strategies, then the associated payoffs, and the form of the game, all were known to all the players in the game. Correct. But that is not true in the sense that in actual sense when the players play with each other, they might be knowing these strategies fully. They may be knowing some partial strategies, possible strategies. They may be knowing the partial outcomes of the strategies that if that are selected by the opponents. So partially, it is quite possible that the players know each other's strategies as well as the payoffs, corresponding payoffs of the strategies. But this information is not perfect. It is imperfect information. Someone is joining, I guess. Oh God, don't do this. Okay. So, what is the motivation for this Bayesian games? What are the objectives? Maybe some reasons why we need the Bayesian games. Correct? If all the players they know what actions are being decided and what actions possibly be taken by the opponents, then I don't think the Bayesian games are required to be studied. But in actual sense, the scenario is something like that. The players they don't know many a times the the actors what they will, or the players what they will play. Okay. Likewise, if there is a war, there are some examples given here which may clarify the nature of Bayesian games and the motivation behind the Bayesian games, and that are very clear in nature. If we see, and you may also observe some of the very good examples around us. Okay, what is happening in Maharashtra right now? That is one we can say one game. Maybe the political game in the assembly elections are coming in. Then how the players, political parties, they are playing, challenging each other and roasting each other. Correct. Uh, Claims are getting, we can say, the things are not known. Anyone is not knowing what is the strategy being played, and every day is a new day for them. And so every day they want to the oversight the others and overtake on the others. See, that is what is. Though we know that there are, I can say, uh, the actors which may, or the agents which may feel the gap between the imperfect information and perfect information. But still, many a times it is quite possible that the information remains the imperfect. Correct? Like warlike situations, we know that what happened in Kargil. So if we were knowing that the terrorists are coming and the army from the opponents are coming in our territory in advance, we could have been prepared for the war. Correct. So we had to fight for our own land, given the uncertain climatic conditions. We Because they were at the top and we were down, so strategically they were having somewhat better position and with the better payoffs. But still, with the tactics and strategies, we conquered that and we defeated the opponent army. So this is very important implication that we anywhere any player is there, the player may have perfect information sometimes not, and the possibilities are there, large possibilities are that most of the times, or maybe we may say probability of not having perfect information is greater than the probability of getting the perfect information, and hence the Bayesian games, they are having great relevance. Okay, so is it visible?
Not yet.
Visible, na?
No, sir. I mean, if the slides we are seeing you right now, not the slides.
Slide you are not able to see?
No.
No, the same slide. I'm talking about motivation for Bayesian games.
Sir, we were not able to see the slides already.
No slide.
So I guess the screen is not shared.
I shared it. I shared it. How it did not come?
Yes,
Now,
sir, we are
now we
able
can
to
see.
see that now.
Oh God, I'm very sorry. I'll just go back and come back. Okay. So this is what I was talking about. That normal form games, what we had, correct? A number of players, then the actions, strategies, then the outcomes or the payoffs. As far as the perfect information is or complete information in case is there, then the players are assumed to know all these things, correct? But it is not real scenario that in real life many a times the complete information assumption does not work, correct? Okay. And then I was talking about this. There are some examples which are given typically, which actually provides the motives for the Bayesian games, why we should have the imperfect information in the game theory. Okay, so we had we can say taken out the assumption of perfect information, and we are trying to just understand some of the examples here. One example we had, then one you may talk about the election or the elections at the center, any election when it is fought, then the opponent parties, the parties playing in that election, they have their own we can say the strategies, and many a times the strategies are not perfectly known to the opponents. Okay, clear?
I can't see the screen.
You're not able to see?
No, sir.
Hello?
So it's
How is
showing
it
your
possible?
camera feed, not the slides.
So it is breaking, I think. I had shared already. Why it is not? Okay, I'll do one thing. I'll share entire screen. Maybe that will help. Is it visible now?
Yes, sir.
That is why I hate this online system. Okay. So there are some examples typically given, but I had taken the Indian examples to which are similar kind of examples of maybe war or the elections. Okay. And the third is the leaders may not know the willingness of the public to pay for a new public library, and therefore don't know if they should provide it or not. Correct. So sometimes the public policies are also something like that. If the public policy is being executed or it may be introduced, many times the executors may not know how the beneficiaries will react to that. Like one example, I may just brief you. When the DBT was launched in the tribal hostels, do you know what is DBT? Do you know how this temperature is to be reduced? I don't know what is happening. Of AC? Now it may work. Okay. So the games are something like that. Many a times the participants in the games, they may not know what the opponents, they take the decisions. Like I don't know how many of you know the auctions, how they take place. You know, many of the movies you must have seen, some auctions are taking place and the bidding is being carried. So many a times it's a very pure competition in a sense that the opponents, they don't know how at what extent the opponents will go, and the competitors may go, and how much we should raise the particular bidding. So this is some examples. Like one is like lobbying and interest groups, which they want to influence the public policies, and that's what we know. Many a times it takes place that from some favorable policies are framed for the for the industry people. There are many cases even in India and United States have been in the discussion that there had taken some lobbying or something like that. So here what is clear is that the opponents, uh, they have imperfect information. So the participants, whoever are there, it is quite possible that some participants, they have more information, some participants, they have less information about the strategies, actions, as well as the possible outcomes of the corresponding strategies. So the Bayesian games are actually based on this pre-assumption that the chances of having the imperfect information are high in real life games, and so one should relook into the game, that is normal form of game, static, but with the incomplete information. And this is what Bayesian games help us in understanding that. And so we'll have Bayesian game in normal form. Now, this game is also known as Harsanyi model. Harsanyi has explained this model. Now, in books, maybe some you may say the alphabets may change. That's the only difference, but largely it is the same. That is the same book which we are using, that is being referred here. And for a Bayesian game, and that is to also have the normal form game with the incomplete information. The players are assumed to have one to n, that is n number of players in the game, and a set of action spaces, that is nothing but these strategies, are denoted as a1, a2 up to an. Okay. Then a set of type spaces for each player. Now this is very important aspect which is introduced here, what this type space is and what is it about. This type space is nothing but the nature or the type of the player is. You know, see, when we say that batsman is coming on the field, then the bowler has to know what the type of batsman it is. There are two batsmen, well-known batsmen are known. These are one is Sachin Tendulkar and another is Rahul Dravid. Do you think that the opponent team will have the same set of strategies for these two different players? Do you think? Just tell your response. Please tell your response.
So they will have different strategies.
What sort of strategies do you think they will have?
So one is a defensive player and one is an offensive player. So based on that, they'll adjust.
Sorry, an important call was there. Correct. Also quite in that could even plays, and sometimes plays some aggressive, correct? So hope can be known, but still the actions may differ, correct? The real life scenario, uh, the not okay, or internet connection. Sorry, is it okay? Am I visible? Hello, audible?
Visible and audible, but not the slides we are seeing. The
Yeah,
Google
yeah.
Meet.
I'll just bring it. Only thing is that what I wanted to just tell you that the type of each of the player is T1, T2, Tn. Okay. So T1, T2, Tn is nothing but the type. I wanted to write whether I am able to do it. I don't know. I'll just check. It's mere waste of time through the technology. Though technology is useful, surely. So a player's type is Ti, which is an element of Ti, is known privately to the player, but not necessarily to other players. Okay, like if I am some type of person, maybe introspective, someone may be aggressive, someone may be calm, someone may be slow in taking decisions. So every person individually, the way they have their own qualities, and so it forms the type, correct? So I'll just check if it's possible I can cast. So here, use the I am able to write, correct? Am I audible?
Yes, sir.
Yes, sir. Okay, thank you. So, oh, sorry. Okay. So I was talking about TI. TI is an element of TI. So if I am talking about T1 is an element of T1, then it is the type of player which is of the set T1. Okay. So a player's type PI, which is element of PI, is known privately to one player, but not necessarily to the other players. Okay, maybe aggressive, maybe some traits in terms of like you must have seen whenever some mergers or acquisitions take place. See, people if they are contesting each other, that's then the game is played, and many times it is not known. Correct? It is not known that what would be the uh, acquire a firm or having merger with the firm and all that. So the type is very important as far as the game is concerned, and so the implication and the payoff is depending upon then now the actions as well as the types of the player. So your payoff, you may say profit is function of not only the strategies but also TIs, that is types. Correct? Okay? Is that clear? Okay. So payoffs that are determined by the players types and their actions. So your UIs are nothing but the payoff, okay, are depending upon the actions and the types of the players. Okay. Are you able to see the screen which I am writing on?
No, sir. We are seeing the slide.
No. Right. Only slide I am writing also. You are not able.
No, we are seeing the slides that you were showing.
Okay. What to do with that? I don't know. Just give me 2 minutes. I log in from the the system. टेक्नॉलॉजी जेवढी कामाची ना तेवढीच ती बेकार पण असते. Not now.
No, sir.
Now you can speak. You can speak from mine. Hello, I'm speaking from Siddhant's phone. Is it now you're able to hear me?
Yes, sir, we can hear you.
Okay. And what about if I am speaking from the system? It is not audible to you.
No.
Just wait. I'm just trying to just switch off this and let us see, and just tell me whether I am audible. Okay. 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 It means that I am not audible from the TV system, correct? But I
Yes,
can
sir.
speak from here. Okay.
Yes, sir.
So we'll do one thing. I'll speak from Siddhant's phone. Okay.
Yes, sir.
Multiple instruments are in. God, where is it? Okay. So my screen is visible to you.
Not yet, sir.
Okay. Good. So mark also is visible. I have written something.
So we can't see the screen. You'll have to share it from
I
there.
have written some X here. Is it visible on the board?
No, we are not seeing anything, any display.
Okay.
At least I am not.
Okay. Just a minute. I will just- Now is it? Now is it?
We are seeing the slides.
Slide on that slide, X is written. Is it?
Yeah, we can see that. Yes.
Okay, good. So,
Yes, sir.
okay. Okay. So I was talking about these TIs, which are elements of TI, that every player type TI, which is element of TI, is known privately to the player, but not necessarily to the other players. Okay. And that's what we were talking about, all these three. That is, one is the players, then the actions, then type space for each of the player, that is T1, Tn. And then we had mapped the payoffs, and that payoffs is nothing but the profits or the outcomes of the game, which every player maps in. Like here, I player is mapping UI. Okay. So UI is the outcome or the payoff. Now, depending upon not only the actions, earlier in our normal form game, we had stated that UIs are the functions of A1 uh, up to AL, correct? Correct? But now it is not. It is in the case of the incomplete information. Now the type of player also enables us to understand what may be the possible action. Actions are there, set of actions are there. But knowing the player, what type of that player is, we may narrow down or filter out the actions or the strategies which the player of a particular type may play. And so here each player has a belief, okay, about the other player's type. So each player has the beliefs, that is understanding, correct, that a particular PI player is of some type. Clear? So the player's type is the PI is the player of I, that is I, having some type. Okay, Ti minus Ti T minus I shows that this is the type which is subtracted from the total Ti space. Correct. So if I have Ti space, then in this Ti, someone is having some to say, I persons T you want, you know, correct? I persons T you know. Then among the all TIs, whatever TIs are there, you subtract the I. And then remaining are not what I say. So you subtract your type, and then you consider the others type, what is there in the type set. Okay. So Bayesian game becomes then the game having the actions or the strategies and the types and beliefs about the opponents and payoff. Okay, so there are 4 components now in the Bayesian game. One is strategies that we had denoted as SIs. Now these are TIs, okay, and these PIs, and these are UIs. So simply the game consists of now 4 components. That is a Bayesian game consists of 4 components than that of the normal game. Okay, in normal game we know that the game was of the actions and the payoffs, correct? So there are 2 components, that is TI and PI are now introduced. In our normal game, we know that the actions were there and the UIs were there, correct? So these were the only 2 aspects in the game. Whereas now in our game, Bayesian game, now the SI, that is the TI, the actions are there, then TIs are there, and PIs are there. So PI and PI are introduced because of the asymmetric information, or what we can say incomplete information about the players. Okay, clear? Right. Now, if we think of the process of playing the game, such games with the incomplete information, then the players lack specific knowledge about the world. The players, they don't have all the knowledge. Okay, so that is what we know. See, for example, if we say 10 candidates are appearing for the interview. Okay. Now, how you will know priorly that how others will perform in the interview? You don't know. Correct? Correct? Because you don't know what type of these and what is the knowledge they have, and so you cannot find your probability of getting selected. So probability of getting selected, it depends on the knowledge what the opponents they have, and which you don't have any knowledge about their knowledge. Correct? So this is the game in real life, that every time whenever we have something, that is something which is, see what happens in the in market, we go and bargain. Correct? Now we don't know the actual price, and the seller doesn't know what we on maximum price will buy the particular product. So the scenarios are something like that. If you say that buyer and seller are the players in the game, and the product is going to be bought or sold, this is game. In that case, what happens is that the two players, they have their own strategies to bargain. So bargaining is on both the fronts, that the buyer and seller both will bargain. Correct? But when they bargain, then they play their strategies depending upon what knowledge they have. They may have knowledge of the product, what are the qualities of the product and all that. But the opponents, that's the buyer and seller, both they don't know about the qualities of the players, each other. Okay, how hard a person may bargain, and then we reach at some Nash equilibrium. But that Nash equilibrium may be somewhat positive payoff for some player which has better understanding about your nature, your type, how hard you are able to bargain, and that is mapped immediately. The buyers are every day they are observing. Sorry, the sellers are observing many buyers, so they know the psychology of the buyers. Correct? At the same time, if we are frequent buyers, then we may know the psychology of the sellers also. So now it is depending upon the qualities of buyers and sellers. That's the type of buyer and seller, whether the buyer and seller will come at the Nash equilibrium, or somewhat we can say some more benefit to the seller and some more benefit to the buyer. Surely seller will not sell its product taking the loss. Correct? So whether you reach at the normal profit giving price or not. Normal giving profit is what? Is the marginal cost only is recovered from the sale. Whether you reach at that or not, we don't know. Correct? So similar kind of scenario is here, that the players lack specific knowledge about the world. Instead, they have perceptions. They have perceptions. They have preconceived notions, and that we call beliefs. Okay? Is that clear?
Yes, sir.
So no one has the perfect information, but some preconceived information about the behavior of the opponent is always there. कि ये ऐसे करेगा. कि मैं like in even we know that in cricket what happens is that if I play the outswinger, then surely the batsman will try to touch the ball, and that the ball may go in sleep with the cut. Okay, so see, now the strategies are played, but at the same time, if you must have seen in some of the movies, I don't remember. So I think Mr. and Mrs. Mahi. In that movie, if you recall, if someone has watched that movie, I don't know how many of you. But in that movie, the Mahi, that is Mahinder, a priori comes to know that what type of ball the player is going to ball. Okay, because how the seam is being taken by the bowler, and what is the gesture of the bowler, and that is the only information, but that may deceive the batsman, correct? And that's what happened also in the game. It is in the movie also it is stated that he did not get selected because only he is deceived by the bowler, and he gets caught at the boundary, and he is not selected. So see, the outcome of the game was not known to Mahinder, but Mahinder tried to understand with his own perception, or the, we can say, preconceived notion about the grip which, or the seam, how the bowler takes, and depending on that he takes the decision. So belief is sometimes it may give success, it may give sometimes failure also. So uh, players, they lack specific knowledge about the world, and that is what, instead of having some, we can say, perfect knowledge, they have some beliefs. Then each player gets a signal about something. Okay, what signal you get? In many players, in many games you must have seen in real time game also. So what you do is, if you are bargaining with the sailors, for example, then what you do कि you bargain hard, and then you realize कि ये इससे नीचे नहीं आ रहा है. Then what you do? You tell the sailor that ठीक है, आपको अगर परवड़ता नहीं तो आप मत दो, लेकिन मुझे यही प्राइस में परवड़ता है, तो I want to pay this price only, and you start leaving that shop. Once you start leaving that shop, that you give the signal that you will not buy now. Okay, and then sailor again recall you, re-invite you, and try to renegotiate. Have you experienced something like that? Have you experienced something like that? Hello? Hello?
Yes, sir.
Yeah. So I'm asking the audience, have you experienced something like that? Okay. I think all of you may be busy in somewhere else and doing your lectures also. Some of you maybe. So signaling is depending upon, or the signals are depending upon the beliefs, as well the type of player, and about the state of the world. That is beliefs as well as type of players. So both of these give some signal. So type of player is one, and the other is belief about the, or the, we can say, the information what you have, perceptions you have about the particular players. So that give you some signal, and players update their beliefs with this new information using the Bayes rule. Now Bayes rule is introduced to update the belief of the players, and then they choose the action that maximizes their expected utility, which is nothing but your payoff, expected payoff, given their best guess that the game theory or the game they are playing. Okay, so we'll see how it is introduced in the course. the intuition for a Bayesian game is nothing but to understand a game of incomplete information as a game of imperfect information with a fictitious player who moves first called nature. Now, here there are players, okay? And the fictitious player is denoted by Harsiaini, because the same word is used here as nature is the first player. Nature is a name, okay? Instead of writing player 1, player 2, Harsiani used the word or the term nature for the first player. So, a fictitious player who moves first is called nature. Okay? So, nature draws a type vector for all players. Nature is a player, okay? Nature is the name of the player. So nature draws a type vector that is the combination. We can say the vector. Vector is nothing but the pair of the types of the players. That T1, T2, Tn. All these are types of the players, and it makes the vector of that. Okay. Then for each I, nature reveals Ti. So for each of the I player, nature reveals Ti to some players, usually including I, and sends the signals to the others. So, nature is the player who reveals the TIs to some players. TIs are nothing but the type of the players, that I am that type of a player, and give the signal. Okay, I am going to be aggressive. I am going to be mute. I am going to be calm. I am such a person. Vagare, vagare. So to deceive the player, I must give you my example. Maybe you may not like it, but still I always try to explore some of the experiences, real life experiences. See, when I faced the interview at University of Mumbai, there were three candidates, myself and two more. I don't name them, but I'm telling you. We were three people contesting the same post. And we met there before the interview. Now, see, I don't know about them. And really, I did not know about them. But they had some information about me. Because when I went there, they replied that the way they introduced themselves, that we know you. Okay. So one was knowing somewhat better, the other was not knowing me that better. So relatively, they were knowing me, I was not knowing them. But I was there to signal. I know how the game was to be played there, because that interview was to be contested. So I wanted not them to tell what I am and to have somewhat, we can say, lower profile. I had some discussion, something like that. I am not interested to join university, even if I am selected. So before the interview, I was interacting with them, and I was telling them that even if I am going to get selected, I may not join the university. Now they had a question that why you came there then. So I was just giving signal to understand them, because I did not have any information. So I wanted to have some, we can say, to form some rule to understand them. Okay. So Bayesian, or we can say Bayes rule, that what they are having in their mind. And then I realized that one is contesting something very hard, which has connections with the panelist. Okay, I realized that in the conversation that one of the contestant was having some connection in the interview panel. And then I realized that I had to take more efforts. Okay, so in the interaction only, I could know some information which I did not have the complete, but we can say I had mapped the probability, conditional probability rather, that if the person has connection there, then how I should prepare myself and I should present myself there. See, this is how a real game is played. So I started giving signal to show the person who was having contact in the panel, ki I am not going to join even if I get selected. So immediately some reply must have come from that person to inform the panelist कि वो तो join होने वाला नहीं, don't worry. Okay? And then we face the interviews. पहला इंटरव्यू एक कैंडिडेट का हुआ, सेकंड वाज माइन, थर्ड वाज द अनदर कैंडिडेट. फर्स्ट इंटरव्यू होने के बाद वो बाहर आया, बाहर आने के बाद मैंने पूछा कैसा हुआ इंटरव्यू वगैरह वगैरह. देन ही सेड वेरी गुड इंटरव्यू, but they had asked some questions I could not answer. So I realized now some more information was added that the one candidate could not give answers to all the questions. So this was very helpful for playing now my tactics. And then when I went there inside, I proved myself at my best level, knowing the signals of my opponents, the players. And then my interview took for almost 30 minutes. And the opponent's interview took only for 10 minutes. That itself gave me indication and signal that I'm going to get selected. Okay. After coming out, again I told, because they came to realize that I am going to get selected. But then I wanted to stop their tactics, actions. And so I told them, even if I am selected, I am not going to come. So these were the signals given from my communication that don't do anything to restrict my entry, because I am not going to come. So this is, we can say, proposition played by my side. And so in the panel, the person who was there, he did not play game there and did not restrict my entry there and said कि ये अगर इसका selection हो भी गया तो ये आने वाला नहीं है. Okay, and I got selected. Now it was me to take decision. Okay, I joined the department. This is how the game, real life game, is also played. Okay, then both of them meet me afterwards and ask me, तुमने तो बोला था यार join नहीं करोगे. Then I told them, see, my father and mother wanted me to join the university. I did not want, but they told me to join, and so I can't refuse them. So I am joining, or I joined the department. So they were not happy, but they may be knowing game theory, they may not be, I don't know. So sometimes it is the real life game we play. We don't know we have played game. We don't know we have played game with the perfect information, or we don't know we have played game with the imperfect information. Okay, so many times we are involved in game, and we don't know, but we give signals. So signals are given, and signals are sent to the others. Then the player choose actions, AI, simultaneously. Player choose actions simultaneously. Okay? Correct?
Yes.
See, similar kind of story is related to our Mitra project. When we got this project, there were around 7 contestants. All were sitting in the same hall. All were presenting. After one, other were presenting, but no one was knowing what the other was going to present, and no one was knowing that what are their capabilities and what they have projects handled and all that. So, see, this was simple bidding type, but it was open bidding where you have presentations, but still you don't have any knowledge what they are going to present and what they want to do for the government of Maharashtra. See, the way we got, for our expertise, we just gave the signals to the parties also that we are better in this and we will do this and all that. So we got this project because we knew that we wanted to give some signals, we gave the signals, and the players were playing simultaneously. Players were deciding their strategies simultaneously. Players were giving signals simultaneously. So the payoffs are realized at the end, which are depending upon strategies and TI. Here is the type of I. Okay. Now, not all players are able to observe nature's first rule, making this a game of imperfect completion whereby players do not know the complete history of play. Okay. So what nature is in mind and how it will play its first move is not that all the players were knowing it. Like what happened in Mitra meeting, that's we can say presentations. First presentation was by Gokhale. The Gokhale was the first mover, then nature was Gokhale. And then we had to present, I think, third or fourth. So even IIM Nagpur presented, IIT Mumbai presented, and then we presented. So we were now knowing some of the things. So we were having somewhat better position in terms of knowing them and how now deciding on our strategies. So when I started presentation, then I knew that they have their own, we can say, areas where they have expertise. We have our own. So I'll play accordingly, and that's the game I played. And so the making this a game imperfect information whereby players do not know the complete history of play, though you can map with the conditional probabilities. Okay, so the strategies what the players in these type of Bayesian games play can be defined as a strategy is a contingent plan that tells the player what to do for every possible type nature might draw. Okay, what nature the player first plays, for that play, what are the possible, you can say, the strategies or the contingent plan you play, that is nothing but this strategy. So for nature also plays the strategy, but nature knows somewhat or having somewhat more information about some of the players and plays this strategy. Now, after getting the strategy of nature, other players define their strategies, knowing the type of nature and the played strategy. So thus, in a Bayesian Nash equilibrium, each player type, not the player, okay, it's a player type, not the player, chooses a strategy that maximizes her expected utility or payoff, given the strategies of all other players types and the possibility of the probability distribution over types. So now here we are going to introduce the probability distribution over the types. So why do we need to consider strategies for a type that will never be realized? That is, once nature has drawn a type and revealed it to some type, some player I, why does it matter what he would have done had he been some other type? So it's again it is giving some introduction to the conditional probability actually. That if I am of this type, then how you will react. If I am of that type, then how you will react. So actually, player type is also revealing some probability, okay, and that probability, if you are able to map and define, then you can have the better position, because the other don't know this his type, but what they do depend on it, and what player I does in turn depends on that. So it's a very important implication of the strategies of the nature. Okay. So how this Bayesian game is defined then, and the Nash equilibrium in the Bayesian game. Now we have defined the game, but we have to define the Nash equilibrium also. Now, because the strategies are functions of types, evaluation of best responses is somewhat complicated. Correct? Because you still don't have the perfect information about the types also, belief, because it's a type is again is built by belief. So it's a perception. It's a preconceived, we can say, a term which you define for some type of the player. And so, in the Bayesian game, the Nash equilibrium is defined as, in the game that is static Bayesian game, G is the game with the actions A1 to AN and types T1 to Tn, with the P1 to Pn. Again, we know that how these P1 and Pn are defined, correct? And the payoffs, utilities, or you can call it payoffs. Payoff 1, payoff 2, payoff 3, payoff n. The strategies are built as S star, that is optimum strategies. Now, why we call optimum strategy? Because that is nothing but the equilibrium strategy. Okay, so strategies are equilibrium strategies, which are defined as S star equals to S1, S2, S3, Sn star, are the pure strategy Bayesian Nash equilibrium. So these strategies give some outcome, and that outcome is nothing but your Nash equilibrium. So if for each player I, and for each player, each of I's type, Ti is element of Ti, and Si star is depending upon Ti, and that solves the problem, that is payoff matrix or the maximization problem. So we say that maximize UI for the actions which are available, that is AI, which are element of AI, and the summation of, see, very important implication is there, summation of what? Summation of payoffs. See, very important implication here. So UI to the UI is function of S1, S2, S3, correct? Strategies. And this AI, A1, A2 are the, we can say AI is the action play. And SI star plus and TI star plus to SI, SN star and TN and T. See, this what it indicates is nothing but the strategies of the other players and the corresponding type of the players. And this is what is important implication, what we had defined, this PI, TI in our exploration of the game, that PIs are nothing but the beliefs. Okay, so beliefs are conditional. Very important implication here is that beliefs are conditional. So the beliefs are conditional beliefs. Okay, and so the sum of this payoff is conditional. Okay, is that clear? So how you map in your actions, strategies, knowing the types of the players, and the depending upon types of player, you build the beliefs, conditional beliefs, and that gives you the maximum outcome of your game. Okay, and so we need some rule to reach this equilibrium, and so we define the Bayes rule to reach the Nash equilibrium. Okay, and what is this Bayes rule about? Why it is necessary, or why it is to be formalized, is that we know that there is no complete information about the world, correct? So if we don't know complete information, we don't have complete information about the world, then how to be rational, and what does it mean to be rational? Because some we can say behavior should be executed knowing the particular aspects in the game, and we know that the information is not complete. And so how, in what way we or the player becomes the rational having the incomplete information. So making the best guess you can based on one, what you observe, and two, your pre-existing beliefs. Very important implication here. See, making the best guess you can based on what you observe and based on your pre-existing beliefs. See, in Indian context, marriage is a game. Okay. Do you believe or not? I don't know. I do believe marriage in Indian context where it's not love marriage, it's arranged marriage. Arranged marriage is a game. And it's a perfect Bayesian game. Okay? And you are playing something being rational, but what rationality is depending upon these two aspects. What you observe and what you have the pre-existing beliefs or the knowledge. Okay? See, it's a perfect example of this Bayesian game. And if I say that in Nasik district alone, 16,000 divorce cases are pending, then I think these games are failed. And they had, we can say, they are to say the outcomes of the Bayesian game which do not reach the Nash equilibrium. Okay. So I say marriage is a Bayesian game, may reach the Nash equilibrium, may not. Because what you observe may not be true, what you believe may not be true. And depending upon these two, you map in your rationality, your rational behavior. Correct? Okay. So here we need to form a base rule having the rational updating. So what we do? See, एक मेरे फ्रेंड है, उनकी लड़की की शादी करनी थी और उनका वो जो प्रपोज लड़का था वो मुंबई में कहीं म्युनिसिपल कॉर्पोरेशन में जॉब करता था. So he called me and said कि यार मेरे रिलेटिव्स है लेकिन बहुत सालों से उधर ही रहते हैं मुंबई में. I don't know anything. See what pre-existing beliefs and what you observe. So what they have observed is that the person has a good job as engineer, and that is observed. But what they have believed is that they have the information. What they so since many years they are in Mumbai, so they don't know. And then he called me to correct the, you can say, to have the correct the signals. The signals तो उन्होंने दिए हैं, लेकिन फिर वो signals में जो भी errors है उनको minimize करना and optimize the decision. So to make the rational decisions, you have to update the, you can say, signals, knowing the type of the person or the player, knowing the, you can say, the beliefs, updating the beliefs and all that, and then you may form some, we can say, rule which is known as Bayes rule. That is nothing more than an extension of the basic rules of the probability theory, which we will now review. I don't know how many of you have done probability. Probability is done by you all?
We had it in the basic statistics class.
Okay, good. So you also know the conditional probability?
Yes.
Okay, good. So there is one example, typical example given to understand the conditional probability. the and the case is given, one example is given. What is the probability that 2 dice sum to 3? Before the die are cast, the event, call it A, occurs with probability 2 by 36, 1, 2 and 2, 1, or we can say vectors. Now suppose the first die comes up 1. Okay. Now suppose the first die comes up 1. Call this event B. Call this event B. What is the conditional probability that the 2 dice sum to 3? Given the first die come up 1. So here the first die is 1 and you have to keep it as it is, and you are throwing the second one. Okay. Now the chance is that when you throw the second die, then anything may come. Correct. So the results may be 4. Expected results may be 4, 6. The expected results may be 6. The die may come up as 1, may be 2, 3, 4, 5, 6. Correct. But what you want is the sum of these 2 die is 3. Correct. And sum of these 2 die is 3. Only possibility or the probability is only 1 out of 6. This is 1 out of 6. These are 6 probabilities, correct? But out of these 6, only 1 qualifies for this result. Okay? Correct? Now what does it reveal is that only one of these outcomes gives 3, so that probability of A is the event which we call it as before the die are cast, the event, call it A, occurs with probability 2 by 36, 1, 2, 2, 1. Now the probability of A, given the condition that B is there. So B is what? B is this one. So this is B. This is given, and then you have to check whether A will take place or not. And then you find the probability. So B is given, and you want to map in what would be the probability of A to take place. And in this case, what will happen is that this is the probability of A conditioned to B as 1 on the dial. Correct? It is 1 by 6. Now this notion of the conditional probability is, if we understood, then the conditional probability that some event A will happen, given that we know some event B happened already, is defined as probability of A given B has already taken place. Given B has already taken place. Okay? That is equal to the probability of A intersection B. Okay? That is the probability A intersection B to probability of B. Similarly, if we assume that we want to find the conditional probability that some event B will happen, given that we know some event A happened earlier, then we find the probability of having B given the condition that A has already taken place. Then probability of B for the event A has already taken place equals the probability of intersection of the B A sets to probability of A. Okay? Now, where the probability of BA or the B intersection A and the probability of A intersection B equalize each other, okay, then what will happen? here in the given example, the probability of AB is equal to 1 by 36 divided by 1 by 6. Why? It's actually 1 by 6. Okay? It is 1 by 6. So the probability of AB is 1 by 6 because we said that 1 we want as B. B is 1 on the die. Okay? So on die, 1 will take place is the probability. We know that this is condition, and then we want to see what happens with the die and second die, that is A. Then A can have 1, 2, 3, 4, 5, and 6. Correct? So what we want is that this should take place, but the probability of having this, it would be 1 by 6. Condition to have the P already happened. Okay. Now we know the conditional probability, but when we say what is the total probability, defining the total probability, the reasons are there for that, because ultimately what we have is that it is not only one event is taking place. It is the many events are taking place, and so the players play the game, and these are again conditional probabilities are being observed there. So if you add all the conditional probabilities, then you get the total probability. Okay, and hence we need to understand the concept of probability, that is total probability. A and A dash are mutually exclusive. If A takes place, A dash will not. If A dash takes place, then A will not. Then, if they are mutually exclusive, if one happens, then other will not, or that cannot. If head is on the surface, then surely tail will not. Okay, because if we flip a coin, then we know that if tail comes, then the head is down. Correct? Down faced. So only one of these two will take place. So they are mutually exclusive. So if it is A, then this, if it is A, then this will become A dash. So if this is taking place, this will not take place. Okay? So we also say that some events like heads and tails of a coin flip are exhaustive in nature. If either one or the other must happen and no other event is possible, so you say exhaustive. So we also say that some events like heads or the tails, heads and tails of a coin flip are exhaustive if either one or the other must happen and no other event is possible. So we say it's exhaustive in a sense that no other event after that event takes place will take place. Okay, no other event will take place. So no, if the event doesn't take place, then no probability also can be computed. So that is exhaustive. So if we know that the event that can take place is 1, 2, 3, 4, 5, 6. In a flip of a, we can say, die, all these are the only possibilities. So the exhaustive amount of observations here or the possibilities here are only 6. Correct? It cannot have 7. Correct? Yes. Why? Because the outcomes are exhaustive, and so the probability is exhaustive. Okay? Is that clear? So, having the, you can say, outcomes exhaustive, the probability also gets exhaustive. So a partition of one, and that's why we know that probability lies between 0 to 1, because it's so probability, it lies between these two, 0 to 1. Okay? Probability of an event always lie between 0 to 1. 1, it says that the event takes place. 0 it says that the event does not take place. Okay. So a partition of all possible events is a collection of events that is both mutually exclusive and exhaustive. So we want to define this total probability. To define that, we know that it is a collection of events that is both mutually exclusive and exhaustive. So a partition of all possible events, okay, that is a collection of events that is both mutually exclusive and exhaustive, and then we will be able to find the total probability. See, one example is given here. If we condition that B takes place first, okay, and in event of B taken place, what is the probability of A1 to take place? What is the probability of A2 to take place? And what is the probability of A3 to take place? And if we find the probabilities of A1 to take place, A2 to take place, A3 to take place, and here now they are exhaustive in nature, that is up to A3. This can lead to A raised to A to A up to N. That is N number of events. Now here events are only 4. 1, 2, 3, 4. 4 events are assumed to take place here. So, but this event has already taken place, that is the assumption. This has taken place, and then whether A1 will take place and what is the probability of A1 to take place, what is the probability of A2 to take place, and what is the probability of A3 to take place. If you measure, that is conditioned to that. A1, the probability of A1 having B taken place. Okay, so probability of A1 having B already has taken place, probability of A2 having already B taken place, and probability of A3 having B already taken place, or probability, if we continue, then probability of AN when B is already taken place. Then if you have the sum of all these is nothing but your probability of A actually as a whole. All A's, A1 to AN, all A's are mapped as a set of A1 to AN. Then in that case, what we are trying to just see is the probability of A. So probability of A or A's is depending upon the probabilities of A1 to AN conditioned to the B has already taken place. And so we know that to know B's probability, now B is equal to, the probability of B is equal to the probability of intersection of A1 B plus probability of intersection A to B, A2 and B, and if it continues, then probability of AM to intersection B. Now we know that already PB is equal to, if you go back, and then you will come to know that PB is the ratio, correct? Of what? If we define this, you go back, we are defining this. Now, if we define this, then probability of A intersection B, probability of intersection A to B is equal to, if you redefine this, then this, if I take probability of A intersection B to left hand side and rest the other side, then it will be probability of B times probability of AB. Correct? So probability of A intersection B is probability of B times probability of intersection, probability of A B, conditional probability. So probability of B times the conditional probability of A. This ratio, now this is equal to this, because I made this numerator and I just shifted this to left hand side, and we got probability of A intersection B. So probability of A intersection B is nothing but probability of A times probability of B of A. Now here it is very important because we are computing the probability of B, not A. So A is there. Okay? Because for this also we have defined probability of B. We also defined that probability of intersection BA. Whether you call it intersection BA or AB, it doesn't make any difference, correct? Okay? So you call probability of B intersection A or probability of A intersection B, the meaning is same. Okay? So here it is written as A1B. This is rewritten. So probability of B when it takes when A takes place, and so these probabilities are defined as the probability of A1 intersection B is equal to probability of A1 times probability of BA. Okay? Because we are defining the total probability of B. Okay? That clear?
Yes.
Then if we extend this idea to have the all corresponding probabilities rearranged, then we get this equation. So probability of B is equal to probability of A1 times probability conditional probability of B when A1 takes place plus probability of A2 times probability of B when A2 has taken place, and if you have extended to the n events as A, and then it will be probability of AN times the probability conditional probability of B when AN takes place. And that's how we, if we now if we just substitute all this and invert the conditional probability, we come to know the Bayes rule. So Bayes rule tells us that how we get or how we go between probability of AB, that's conditional probability of AB, and conditional probability of BA. It states that the probability of AB, that is conditional probability of A, given the B has taken place, is equal to, now what we have defined, see very carefully, what we have done, we knew that this is nothing but your probability of A intersection B, correct? Now we have defined probability of A intersection B is equal to this. Okay? Probability of A times probability, conditional probability of BA. And similarly, similarly you can define it for B also. But here we will define for the conditional probability of for one only. We can derive this quite easily starting from the definition of the conditional probability. That conditional probability of A when B takes place is equal to probability of A intersection B divided by probability of B, which is also equal to the probability of B intersection A, because we know that the associative law is there as far as the intersection is concerned, set of intersection. And then this is same. So here it is written like this because of this relation. Because we know that this is same to this and this is defined as this, and so we have defined conditional probability as this. So we can expand this denominator using the law of total probability, which we have already computed. The probability of B we have already computed, correct? Probability of B is computed here, and that is nothing but this. And if we substitute probability of B, okay, in this equation, then this becomes ratio of product of probability of A to conditional probability of B when A has already taken place divided by total productivity of B. Sorry, total probability of B. Okay. See, one important implication, if you see, this is a nuclear example is given, but I remember, see, though we know that some event may take place, so precautionary measures are taken place. And the probability of event, that's a, we can say, accident event, though is 0.1. But if you are not ready with the belief and perceived, or we can say pre-conditioned scenario that 0.1 also may take place, and so we should be ready. So we should be ready. See, in recent years, last 2 to 3 years, we have seen many railway accidents. Many railway accidents, where the accident probability is 0.1 maybe or 0.2 maybe, but still that has taken place. So whether we had some probability distribution computed and accordingly some actions or the strategies were played off, we don't know. Similarly, if you remember Bhopal gas accident, that again was human error. Though many of the, we can say, signals were given that the gas chamber is having some problem. Gas chamber exceeds the gas, the amount of gas which has its capacity. Every signal was given, and the information also was there. Though it wasn't complete, but the information was there. So in the event of imperfect information, what happened is that Bhopal gas tragedy, accidental tragedy took place, which still people are suffering from. It was human error of only knowing the Bayesian incomplete information form. Okay, so similarly, if you see the Bombay blast which had taken place in Mumbai, 26/11 we call, correct? So we know that the probability is 0.1, but still we have to be ready, correct? So we have to have the conditional probabilities, not that all the time just see that this event will not take place. No, किसी की हिम्मत नहीं होगी मुंबई आने की. हो सकती है, 0.1 probability is there. And so depending on that 0.1, we should have the, you can say, strategies and the actionable plan, executable plan, so that we can tackle any such scenario. So it's very important that and this is not only in the events of the accidents or something like that, but the public policy also. Like corona, which was giving signal in the world, we had sufficient time to prepare ourselves, but we taken it very easily, and we did not have that serious approach towards corona. And though the event was taking place, we could have defined the probability of B. Okay, the B was taking place. Probability, we could have just guessed it. What is the total probability, and then we can define the probability of A to take place, whether it will expand in India. A is India's condition to be in the world. So here, see, is a Bayesian game is very beautiful in a sense that it can fit in any of the scenario. And that's the, we can say, the beauty here. And you can just see what can go with this. See, I'm not going to go in this example. You just go through. But Bayes rule, it is applicable in many of these scenarios. The examples are given. I don't go in all these examples, you just go through and try to just understand it. I wanted to only just explain the Nash equilibrium is nothing but your decision when you take to have the probability of A event in condition when the probability of B is already known. So this is your equilibrium, that the A event will take place given the B event. So depending upon based on this, actually this whole of this rule base rule is defined, and then the idea is expanded to form the normal form game in case of the. There are many examples. You can just go through all these examples. And we have some examples related to public goods and incomplete information. Okay.
Turn around the company just like
we'll stop here. We will.
he did when he
take
was hired to run
one
Chipotle in
more
2018.
lecture, but now I don't think I should take it here. I will take from home only. Only you just suggest me a suitable time of your discuss yourself, and then you tell me that this is suitable time for us. We can be home, and then you can be at home, and we can do that. And here, if I do, again, these technical problems are there. I think I'll just make use of normal presentation and just make it if it's possible. Okay.